Hello again, Math 1 students, and this is section 12.3, Proving Triangles Congruent by SAS. So today we're going to use the side-angle-side congruence theorem, and we're going to solve real-life problems. In other words, we're going to be doing quite a few proofs so you get the hang of how this is going to work. Now in section 12.2, we had to find 6 corresponding parts congruent for triangles, 3 pairs of corresponding sides, 3 pairs of corresponding angles, 6 total things we had to show that were congruent. Beginning in this section and in the following few sections, we're only going to need 3 things to be congruent to have congruent triangles. And the first rule is what's called SAS, which stands for side, angle, side, and the order of the letters matters. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 angles are congruent. So in this case, AB is congruent to DE. Notice the 1 hash mark. Angle A is congruent to angle D. And side AC is congruent to side DF. Then triangles ABC and DEF are congruent. Remember, you had to have the letters in order. So notice A goes with D, B goes with E, C goes with F. Now this idea of an included angle is very important. The included angle of 2 sides of a triangle is the angle formed by the 2 sides. In other words, it's the angle between the 2 congruent sides. So for SAS to work, the angle can't just be any of the 3 angles in a triangle. It has to be the angle in between the 2 congruent sides. If it's the angle that's not in between, then you do not have SAS. So again, SAS requires that the included angle, the angle that is congruent, to be the one in between the 2 congruent sides. So let's use these proofs to see how SAS works. We're given BC is congruent to DA, you can tell by the hash mark. BC is parallel to AD, again you can tell by the arrows. We're going to try to prove that triangles ABC and CDA are congruent. So the first statement you're given is BC is congruent to DA. And that is given. Now notice I put an S besides the statement. I'm going to be using these labels to indicate what parts of the corresponding parts we need to show triangles congruent. You don't need to do that. I'm just using it as an illustration. Next, we are given that BC is parallel to AD. And that's given. 3, angle BCA is congruent to angle DAC. So BCA and DAC. And that is because of the alternate interior angles theorem. So you have alternate interior angles because you have parallel lines. So alternate interior angles are congruent. So now we have 1 pair of angles congruent. Statement 4, AC is congruent to itself. And that is because of the reflexive property of congruence. Now notice we have a second side. So the angle that we have congruent, angle BCA, is congruent to angle DAC. So the angle that's congruent is in between the 2 congruent sides. Therefore, triangles ABC and CDA are congruent by SAS. Now notice SAS applies because the 2 sides that are congruent surround the angle that is congruent, the included angle. And so what you basically need to show is that the 2 sides are congruent and the angle in between them is also congruent, and then you have SAS. 1b, given that B is the midpoint of AD and ABC and DBC are right angles, prove triangle ABC is congruent to triangle DBC. So let's take a look at how this one works. Statement 1, B is the midpoint of AD. And that is given. Statement 2, AB is congruent to BD. How do you know this? By the definition of a midpoint. So the definition of a midpoint says that if B is a midpoint of AD, you end up with 2 congruent segments, AB and BD. So AB is congruent to BD. Now we have our first side. Statement 3, angles ABC and DBC are right angles. And that's a given statement. Statement 4, angle ABC is congruent to angle DBC. And that is because of what's called the right angles theorem. This basically says that all right angles are congruent. So since ABC and DBC are both right angles, they have to be congruent to each other. So now we have a side and we have an angle. Now we need to find a second side that we can say is congruent. And statement 5, BC is congruent to itself. And that is by the reflexive property of congruence. So notice again, we have side, AB is congruent to BD. We have angle, two right angles, angles ABC and DBC. And we have a second side. BC is congruent to itself. And notice that the angles that are congruent are included. They are in between the pairs of congruent sides. So statement 6, triangle ABC is congruent to triangle DBC by the SAS rule. So again, SAS requires that you have three things congruent. And again, the important thing is that the angle in between the two sides has to be the one that's congruent. All right, example 2a. In the diagram, segment QS and RP pass through the center M of the circle. What can you conclude about triangles MRS and MPQ? So this is going to be another proof. So first, why is SM congruent to MQ? Why are these two congruent? Well, they're all radii of circle M, and for the same reason, RM is also congruent to MP. They're all radii, or radiuses of the same circle. All radiuses or radii of the same circle within one circle are congruent to each other. So finally, we want to find an angle. Why are angles SMR and QMP congruent? What kind of angles are they? Well, they are vertical angles. Therefore, we have two pairs of sides, SM and MQ, RM and MP, and we have the congruent angle in between them, angles SMR and QMP. Therefore, triangles MRS and MPQ are congruent. Again, notice that the order of the sides matters. So MRS is congruent to MPQ. Actually, in this case, it doesn't really matter because all radii are congruent. You have isosceles triangles. So in this case, you had a couple options with the order of the letters. But normally speaking, the order of the letters has to go together. All right, example 2b. What can you conclude about triangles PTS and RTQ? Now, if you look at the diagram, you're given some congruent segments. You're given that PT or TP and RT are congruent, and you're given that ST and TQ are congruent. So now you have two congruent sides. You need to find that congruent angle, and it looks like you want to use these angles here. So the included angle, why are they congruent? Well, angles STP and QTR are congruent because vertical angles are congruent. Like I said in the previous class, you're going to be using a lot of reflexive property. You're going to be using a lot of the vertical angles congruency theorem. So here it is. We saw the reflexive in the previous examples. So therefore, triangles PTS and RTQ are congruent by SAS. Now notice PTS, that's the order from one hash mark to the angle to the two hash marks. That has to match up with RTQ. R, one hash mark, T to the included angle, Q to the second hash mark. So triangles PTS and RTQ are congruent. If you have the letters in the wrong order, your answer is wrong. Let's end with this proof. You are making a canvas sign to hang on the triangular portion of the barn wall shown in the picture. You think you can use two identical triangular sheets of canvas. You know that RP is perpendicular to QS and that PQ is congruent to PS. Use the SAS congruence theorem to show that triangles PQR and PSR are congruent. So we're given PQ is congruent to PS, and you're given that RP is perpendicular to QS. So let's see what we can do here. So here's our proof. Here's your given statements, and there's the statement you're trying to prove. Statement 1, PQ is congruent to PS. So notice I don't have them in this exact same order. It doesn't matter. The order with some of these statements doesn't have to be exact as long as they follow a logical order. And that is given. Statement 2, RP is perpendicular to QS. And that is also a given statement. Now, what does it mean when two segments are perpendicular? Statement 3, angles RPQ and RPS are right angles. And that is the definition of perpendicular segments. Definition of perpendicular segments says that if two segments are perpendicular, they form 4 right angles. So 2 of those 4 right angles are RPQ and RPS. They are both right angles. Statement 4, angle RPQ is congruent to angle RPS. And this is because of, again, the right angles theorem, which says all right angles are congruent. So notice the logic that you need to follow. You have perpendicular segments. Perpendicular segments, by definition, create right angles. And then by this rule, right angles are congruent. So you can't just go straight from perpendicular to the congruent angles. You need to first establish perpendicular lines, create right angles, which means right angles are congruent. So now we have a side, we have an angle. Next, we have statement 5, RP is congruent to itself, and that is the reflexive property of congruence. So we have one side there, we have the angles, and we have the second side. The angle that's congruent is in between the 2 congruent sides, which leads to statement 6, triangle PQR is congruent to triangle PSR. And again, this is by SAS. So you're not going to need to use the rule that we used in section 12.2 where all corresponding parts are congruent. That rule is already outdated. We needed to go through that section so you saw how you get from congruency to where we are now, where you don't need as many rules. That's it for section 12.3.